When we picture a galaxy, we tend to imagine a tranquil pinwheel of stars spinning in the cosmic night. Astronomers imagined something similar, that disk galaxies like our own Milky Way had reached their present states billions of years ago. Now, a study led by Susan Casson at NASA Goddard has turned this thinking on its head.
We find that disk-like galaxies become progressively more ordered with time. This was a surprise to people in the field because we thought that galaxies already 8 billion years ago were going to be very much like galaxies today, whereas that's really not the case. Over this period of time, galaxies spin faster, their amount of disordered motions that they harbor has decreased, and their total energies increase.
Over the past 8 billion years, disk galaxies began as train wrecks and then evolved into the orderly systems we see nearby today.
We found out how fast they were rotating and how much disordered motions they have from spectra from the Keck telescopes. And then in order to interpret the rotation measurements, we needed images from the Hubble Space Telescope to tell us how the galaxies were oriented. So we find the mass of a galaxy plays a large role in how organized it is. The most massive galaxies are the most well organized at all times, and the least massive galaxies are the least well organized at all times. So on average, the percentage of galaxies which are settled increases with time. Here you're seeing it for the higher mass systems. It's also the case for the lower mass systems. The percentage of galaxies which are settled just increases with time, but the overall percentages for the lower mass systems are always lower than the higher mass systems. We've yet to figure out why this is. In our models of how galaxies evolve, we find that galaxies are possibly more disordered in the past because they're bombarded with more material. There are more small galaxies that accrete onto it, there are more major mergers of galaxies, and there's more accretion of gas. From our models, we expect that this constant bombardment should slow down with time. And this might be why we're finding this in the observations. And what we're finding might also be due to a decreasing amount of supernovae with time. However, the simulations as they are now are really only at the stage where they're giving us clues as to what's going on. In order to get the detailed measurements to really find out what's going on, we're going to need the James Webb Space Telescope.
This new picture tells us that disk galaxies like our own Milky Way experienced a rowdy past for a much longer time than previously imagined, a period that includes the formation of the solar system and the origin of life on Earth.